How y'all doing? Good, huh? Real good. Let's see how today goes. Last night I had fever and chills and all that good stuff, you know. So I woke up this morning. I feel a little better. So I'll try and stay back so I don't get anyone sick here. But I don't know if I'm going to have enough to go the whole class. We'll see. All right, just so you know. But we have a lot to do, so I didn't want to miss today and put us behind. So we're going to do 3.4, 3.5 today. I'm going to kind of blend those into kind of one big topic rather than going two sections. And then on Monday, we're going to review for our test, which is next Wednesday. So make sure you're here Monday. I'm probably going to send an email. Let's see, for Monday, I'll probably send something out. So check your email. Let's say by Saturday, because what I would like to do is send you the review for you to look at over the weekend, for those of you who want to do that. And that way on Monday, it's not the first time you're seeing what I'm going to be asking on the test. And then on Monday, we will go through that review, and then on Wednesday, you'll take your test. Okay? So let's get started. Are there any questions over homework? Yes? 43. Is that the one with all the fractions? 1/2, 3/5, that one? Okay. So number 43 in the homework, it gives you 2 points. 1/2, 3/5, and 1/4, -4/5. Those are the 2 points, and it's asking you here to find the slope of the line that passes through the 2 points. So remember last class we had the formula. M is equal to y2 minus y1 over x2 minus x1. And we would label the points. I told you last class it did not matter which one you choose. You could have called the first point x1, y1, or you could have called it x2, y2. But that's the way that I'll do it. Is that the way you did it also? Yes? Okay. So slope will then be the y2, which is -4/5. Subtract from that, because the formula says minus, right? Subtract what? 3/5. Then divided by 1/4, that's x2, and then minus 1/2. Now, in the numerator, you have two fractions. They actually already have the same denominator, right? 5. So to subtract those, all we do is look and just go across the top. So -4, I take away 3. That should give me -7 over the common denominator, which was 5. And then on the bottom fraction, I actually have to get a common denominator. So what's common denominator, or LCD there? 4. So what I could do is I could take the 1/2, I can multiply 2 on top and bottom. And if I do that, I'll get a 4 on the bottom. So that bottom becomes 1/4, take away 2/4. Is that okay? They have the same denominator. So I do 1 minus 2, which is -1, and then over 4. So right now I have -7/5 over -1/4. And at this point you have a complex fraction. You have fraction over a fraction. So just remember, when you have a fraction divided by a fraction, we really have this, -7/5 divided by -1/4, right? That's really what that means. And division is the same as multiplication of the reciprocal. So I can rewrite this as -7/5 times 4 over -1. So just flip the other fraction over. And now, because it's multiplication, you just multiply straight across. So you get -28 over -5, and a negative divided by a negative is positive, isn't it? So 28/5 is the slope. That help? Okay. Anything else? Pardon me? Oh, it would still work. Did you have, instead of that, did you have 2/8 minus 4/8? Then that should have turned out to be negative 2/8. Did you leave it like that, or did you reduce it to negative 1/4? Where, right here? Negative 2/8. You just left it like that? Yeah. Then what you would do is you would have had this. I'll do it in red over here on the side. You would have had negative 7/5 over negative 2/8, and then you would have rewritten that as negative 7/5 divided by negative 2/8, and that would have, sorry, I'm all over the place here. That would have changed to negative 7/5 times the reciprocal, 8 over negative 2, multiplying straight across, negative 56 over negative 10, and then it would have reduced to, what, 2 goes into each of those? So it would have been 28 over 5, and so it would have been the same thing. 56, that's technically, it's not wrong, it's just not reduced. Yes. Well, you don't have to, but I mean, it's not wrong. It's just not fully simplified, that's all. It's kind of like, writing the fraction 4/8, top right corner there, 4/8. I mean, that's 1/2. It's not wrong to say 4/8, but we like to reduce all the way. I mean, that's the same as negative 4 over negative 8 also. But usually I won't write, if there are two negatives, I won't write both negatives. I'll just cancel them out. Yes? You try and find a number that goes into both of them. So like on the 56 over 10, you just mentally just kind of look at those numbers and say what number goes into both. Since they're both even numbers, 2 goes into each one, right? Since they're both even. So start with 2. 56 divided by 2 is 28. 10 divided by 2 is 5. And then you start looking at those two. Is there something that goes into those two? Well, the only number that goes into 5 is 5, right? But 5 doesn't go into 28. So, I mean, there's other ways to do reducing fractions, but that's the way that most people at this point have gotten, I guess, in their head, that's what they're doing, trying to find numbers that go into both. Okay. I'm going to clean some of this up so it doesn't confuse people later. Okay, moving along here. Let's start 3.4 and 3.5. Basically, what we have up to this point, okay, if you recall, what we've done so far is that if you're given something like 2x minus y equals 10, you should be able to graph that line. That was the first thing we started with in this chapter. Remember how you would graph that? Yeah, you do. You find the x-intercept and y-intercept and draw a line, right? That's how we did that. X and y-intercept, draw a line. So we should be able to do that. Given that, we can sketch line using the x, y intercepts. That's what we can do so far. We also know that x equals 4 is what type of line? If you just have x equals a number, that's a special type of line. What type of line is it? Vertical. Vertical line. If I have y equals -2, what type of line is that? Horizontal. Okay, that was the second thing we've talked about so far. The third thing we talked about was parallel and perpendicular. Parallel perp, right? And then the fourth thing, we talked about the slope, which was m, right? And we had a formula for that. So that's kind of where we are in terms of lines. That's where we are right now. Today what we're going to do is we're going to look at a couple of other ways to graph lines. And sometimes it's easier than what we did earlier. Like on part one here, we did x and y intercept, and that's what we used to graph. The way I'm going to show you today is sometimes a better way to do it than that. So let's start with that. I'm going to give you what's called the slope-intercept formula. The slope-intercept form of a line. Now this is going to be a formula, and guess what that formula is going to have in it? What two things do you think? If this is the slope-intercept formula, then it should have, the formula should in some way give us the slope and then in some way give us an intercept. So let's take a look at the formula first. It's this: y equals mx plus b. Now, if I tell you right now that m and b are numbers, okay? M and b are numbers. That means x and y are variables, right? Then isn't this a linear equation in two variables? Yes? And we said linear equation in two variables, that's a line. So this is a line if we graph it. But when it's written like this, the m is not just some number, it's a very special number. M is the slope. And remember, slope told us whether or not, like how to get from one point to the next, rise over run. And then the b here by itself will always be something. So I'm going to point this out right here. This is our slope. And the b here will always be the y-intercept. Always. All right? What I'd like for you to notice about this equation is that what variable is isolated? What variable is by itself? Y. And there's nothing in front of y, right? So this formula says that if you can somehow take a linear equation and get the y by itself, then the number in front of x should be your slope, and the number by itself should always be your y-intercept. So let's see if we can make sense out of this. Let me give you an example. If I asked you right now to sketch 2x plus 4, no, let's make it 5y, equals 10. If I asked you to sketch that, you could do what we did before, right? What did we do before? X and y intercepts, right? Let's do it that way, and then I want to do it using what I'm showing you today. And I want us to see the difference between the two. All right, so let's do it the old way. The old way, I find the x-intercept. How do we find the x-intercept? Good. Set y to 0 and solve for x. So let's do that. Go into the original equation. Replace your y with 0. If you replace y with 0, what do you get? 2x equals 10, and that means x is 5. So all I did there was divided both sides by 2, right? That gives us the point 5, 0, right? That's a point on our line. We've done this before, right? This isn't brand new stuff right now. Now let's find the y-intercept. How do you find y-intercept? Set x to 0 solve for y. So what happens if I go to the original problem and I set x to 0? What am I left with here? 5y equals 10. And that means y is 2. And so I can look at this as the point. Let's see, x was 0, so y must be 2. And that's another point on my graph. Yes? So now I could just go draw this. I have an x-intercept of 5, 0. Where does that go on my picture? Where's the point 5, 0? Right 5, right? And don't go up and down? So 1, 2, 3, 4, 5. I'll put a blue dot there. And then my y-intercept is 0, 2, so that just means up 2 on the y-axis. Put a dot there. And I draw a line through the 2. So that's what we've done before, right? Now what I'd like to do is I'd like to do the same problem right now using the slope-intercept formula. So the slope-intercept formula, like I had put up here a second ago, says that if you can get y isolated by itself, the number in front of x is your slope, and the number by itself is your y-intercept. So let's see how we can actually use that to draw this line a completely different way than we just did here. So what I'm going to do is this. I'm going to take this, I think I'll do this on a new sheet. I'm going to take 2x plus 5y equals 10, and I'm going to first try and solve for y. So how can I get this y by itself? I first have to get the 2x off the left side. How do I get the 2x off? Subtract it, right? So subtract 2x on both sides. So I take away 2x here. I take away 2x on the right. It goes away on the left, so all I have is 5y equals. Now on the right side, can you put 10 and negative 2x together and like make it like 8x or something? Or no, they're not like terms, right? You can't combine them. So I'm just going to write them in order, putting the x term before the 10. So that's the same as negative 2x plus 10. Do you agree? We almost have what we're supposed to get, right? We're trying to get y equals mx plus b. The problem is that in the formula y equals mx plus b, we don't have a number in front of y. Over here we do still. It's a 5, isn't it? So divide both sides by 5, and you'll have just y. So let's do that now. Divide both sides by 5. Now look at this. When you divide the right side by 5, you actually divide each term by 5. So if there are two terms over there, you have to divide them both by 5. What happens on the left side? What do we get? Y. On the right, well, that's just negative 2 over 5, right? I'm not going to do anything with that. I'm going to put the x to the side of it. Plus, what's 10 divided by 5? 2. Y'all notice how I did the negative 2 over 5? See how I put it out in front of the x? Okay. You could put the x up on top with the 2, but it means the same thing as putting the x to the side. So does this now match that formula in the top right? Yes, right? If we do this way, then m is negative 2/5, and b is 2, right? B is the number there. So the question is, can you graph that line using this information? So let's see how we would do that. I'm going to do my graph over here on the side. So you help me. What does the slope allow us to do? What does the slope tell us, I guess? So you're saying the slope tells you that if you are on the line, it tells you how far to go up, down, and left, right. Right? The slope tells us how to get from one point to another. But the key to that is that you have to start at a point that you know is on the line. So what point do we know is on the line? Well, according to the formula, the B is our y-intercept. Not our x-intercept, our y-intercept. So that is a point on the line, isn't it? So that's where I will start. So I'm going to start by going up 2 on the y-axis and putting a dot there. And I'll draw an arrow from the 2 to here to let you know that's where that came from, right? The B being 2 told me go up 2, draw a dot. That dot lives on my line. Now, to get to another point, I use my rise over run. And what does negative 2 over 5 mean? Remember, it's rise over run. So if your rise is negative 2, I actually go which way? Remember, the top is rise. So negative 2 on top means go down 2. And then the bottom is going to be your run, which is left or right. So with 5, positive meant run, go to the right. So from that dot I drew, I need to go down 2 to the right 5. And if I do that, look at where I am. Isn't that exactly what we got doing it the other way? And then we can just draw a line through it. Now we could sit here and debate like which way was better, you know? The key to this though is that you should be able to do it both ways. And on the test, what I'm going to do is I'm going to give you problems and I'm going to direct you. Okay, sketch this line using the intercept method. That means the first way we did this. Then I'll say sketch this line using the slope-intercept formula. So you have to do it this way. So I want you to be able to do both. That sound okay? Yes. Y equals mx plus b. You feel free to put on cheat sheet. Get a tattoo if you want. You can get a tattoo on your arm of it. That's fine with me. And you can do that instead. It's a good idea. Okay. Let's try one more. How about is that a linear equation in 2 variables? Is that a linear equation in 2 variables? Yes? You have 2 variables, right? It's an equation. They're linear. So that's a line. I'd like for us to sketch this using the slope-intercept form. So in other words, make it look like y equals mx plus b, and then just do what we just did. So that means you have to solve that for y. How would you like to solve that for y? How would you like to get that y isolated? There's all sorts of different ways to do it. So what do you think you would do? So you're saying to get this y term by itself, get rid of the 15 and the x. You can do that, but to do it, you have to take away 15 and take away x on both sides. Right? Okay, that's fine. Or you could say plus 3y and it would go to the other side. Either way. So let me do it this way. I'm going to go with the first way that was proposed, not because it's better, it's just that's what was first suggested. Negative 15 on this side. I need to subtract 15 on that side. I take away x on the left. I take away x on the right. Okay, everything on the left cancels except negative 3y equals, now on the right, how should I write negative 15 minus x? Yeah, negative x take away 15. So we always want to put the x term first because that way it'll look like y equals mx plus b. What now? Divide both sides by negative 3. Negative 3, negative 3, negative 3. On the left side, we should just have y. Now on the right, what is going to be the number in front of x here? Well, that's a negative 1 right there, right? And I'm dividing it by negative 3. Negative divided by negative should be positive. Positive what, though? 1/3. 1 on top divided by 3 on the bottom. So this should be 1/3, and then put the x to the side. And then what's negative 15 divided by 3? Plus 5. Does that look like y equals mx plus b? Yes? So to graph this now, what I'm going to do is start where? 5 where? On the y-axis, right? So I'm going to take my b, which is 5. Let's just go, let's say 1, 2, 3, 4, 5. I'll put a dot there at 5. And then how do I get to another point on my line? The slope says up 1 over which way? Right. Right, not 5. Right, 3. Right? Well, that's if you would have left them both negative. Remember how originally it was negative 1, negative 3? Had we left it negative, negative, then you would have had to have gone down 1, left 3. But if you leave it, if you go positive over positive, then you should follow what that means, which means up 1, right 3. So I'm going to go up 1 from here, and to the right 3. 1, 2, 3. And I'm do my best to make it look decent. And if I wanted to get another point, just so my drawing would be better, what could I do? From that point, go up 1 and right 3 again. And you can just keep doing that, up 1, right 3, up 1, right, until you have a bunch of points and just connect them. But I'm going to be happy with that. All right. Next example. Write the slope-intercept form of a line with slope -2 and a y-intercept of 0, -3. Am I asking you here to sketch a line? No. All I'm asking for you to do is give me the slope-intercept form of the line. That means I want you to write y equals mx plus b. And I give you 2 pieces of information. What do I give you? The slope and the y-intercept. So I've given you everything you need, right? So I'm going to write down first, the general formula is this. I've given you the -2 is your slope, that's m. And what's the b? The y-intercept. Now, I gave you the y-intercept as a point. So which part of that point is the b? The -3. Okay? So you don't write the whole point there for b, you just write the -3 in there. So what should the formula be? Y equals -2x minus 3. That's all. Now, the next one I'm about to do is similar to this, but a little more challenging. All right, let's see if we can figure this one out. Write slope-intercept form of line through 5, -4, and with slope 1/2. What's different in this problem than in the one before? The 5, -4 is not the y-intercept, is it? Yeah, what we have is a point on the line, and then how to get, the slope gives us how to get from one point to the next, right? But the way you attack this is very strange. So just see if you can follow me on this, all right? Does everyone first understand that this is different than the previous problem? Okay? We still have the slope, right? That's been given, but it's that point they gave us isn't the y-intercept. So watch what I do here. Here's what all slope-intercept forms of lines look like. And the only thing I know right now is the 1/2, don't I? Right. So I can replace the m with 1/2. Other than that, I don't know what the b is, right? Y'all agree? Now check this out. If this point lives on the line, right? If it does, which they told me that point, our line goes through that point, then that means that this point should satisfy the equation of the line. Meaning if I put 5 for x, the y should be -4. Right? Remember in the very beginning of this, I gave you an equation. I said, hey, someone tell me an x and a y that makes this true. And we were playing with it. What we're being told here is that this 5 -4 makes it true. So I'm going to come back here. I'm going to look at this. I'm going to say, hey, look, the thing that I want is the b, right? I really would like to know what b is, and then I'd be done. But the only other piece of information I have is that I know that when x is 5, right? When x is 5, the y that comes out should be -4, right? So what I'm going to do is I'm going to kind of put a little squiggly line under this, and I'm going to do something. Right here in this equation, I'm going to rewrite it. I'm going to replace y with what do you think? -4 must equal 1/2. Then I'm going to replace my x with what? 5. So times 5. Then plus b. Do you see that? Now this is an equation, isn't it? But it only has one variable in it, b, which means you can solve for b. And that's what we have to do now. We have to use that to solve for b. So what's 1/2 times 5? And don't get on your calculator, just what's half of 5? Well, rewrite 5 as 5 over 1, right? And then multiply straight across. Isn't that 5 halves? 5 over 2. So I have -4 equals 5 over 2 plus b. Now how can I get b by itself here? Subtract 5 halves on both sides. I'll do that right up here. So I take -4. I'm going to subtract 5 halves on the left side. On the right side, I subtracted 5 halves and it went away, didn't it? So I didn't really show that, but underneath this, I subtract 5 halves. I subtract 5 halves. On the right side, it goes away. I just have the b. On the left side, I have to figure out what that is. And what are you going to have to do to figure that out? Common denominator. So rewrite that -4 as -4 over 1. And then rewrite -4 over 1 as -8 over 2. What did I just do there? How to get -8 over 2? How did I get -8 over 2? I took -4 over 1. I multiplied top and bottom by 2 so that I could get the same denominators on the bottom. Right? trying to subtract two fractions, I have to have same denominators, so I multiply top and bottom here by 2 so that I get the same denominators. And now I can do subtraction. So what's negative 8 over 2 minus 5 over 2? Negative 13 over 2. So B equals negative 13 over 2. And now, don't we know what B is? We have B, don't we? So we can just take that and plug that right back in here, and we've got our equation. So I'm going to come up here, and I'm going to say, now this turns into y equals, we had 1/2 x, and then we just found B was minus 13 over 2. That's a little more involved, isn't it? All right, I'm going to move on. Next example. Find equation of this line. So I'm going to cheat here a little bit. By bringing in my graph paper. You don't have to draw this precisely. You just need to see it and understand what I'm doing. Okay, let's say I have a line that does this. What's the equation of that line? So, well, let's just talk about what we have. What is this point up here? That's your B, isn't it? That's your y-intercept? The only other thing I would need to know is M, right? Can you tell what M is from this picture? Okay, how do I get from that point down to that point? Rise is actually going down how many? 1, 2, 3, 4. So my rise is -4. My run is 5, 6. So that's -4 over 6, isn't it? So my equation is y equals -4 over 6x plus, right, plus what? 4. Now we would reduce that fraction. We wouldn't leave it as -4 over 6. We'd put -2 over 3x plus 4. Do you see that from the picture? You can sometimes recover the equation. All right. Try this one. Find equation. Well, I can't draw a straight line for my life. Okay, I'm going to need some help from the computer here. Let's say that each of these is 1 unit. What's the equation? Can you all see the dots okay on there? Okay. Well, we know it has to look like y equals mx plus b, right? Do you know what m is? Yes? What is it? Six over 2. How are you getting that? Rise over run, right? How much do you rise by? All the way up to here, that's 6, right? How much do you run by? 2. 6 divided by 2, right? This is 2 here. Rise and run. Rise divided by run. So 6 divided by 2 is 3. So we know the slope is 3. Y'all agree? What's the y-intercept? 0. Good. Where does it hit the y-axis? At 0. So our equation actually just looks like this. Y equals, what did we say m was? 3. X plus 0, so don't put anything. You're done. Y equals 3x. All right, last topic, and we're going to move on to the next section. Are these parallel, perpendicular, or neither? Is this the way you spell neither? Okay, so why is it that you don't spell neither? I thought it was I before E except after C. Did anyone else learn that? Well, this is I before E except after C. That's an N in front, so why is it not I before E except after C? That's right. It's just English, and that's why I'm not an English major, because that stuff drove me crazy. I couldn't understand why it was that sometimes a rule didn't apply. In math, the rule applies always. It's not sometimes we do that and other times we do this. It's always that way. You know what I'm saying? Like in English? I mean, of course, there's like certain things like grammatical mistakes you can make. You forget to end a sentence with a period, things like that. But there's so many things that are subjective in English that it's not my cup of tea. Maybe you like it. I don't. So neither, and E-I-T-H-E-R, right? It's possible that two lines can be parallel, perpendicular, or neither. So hopefully you remember what it took earlier to be parallel. I'm going to give you two lines, and I'm going to give you their equations. And I just gave you the equations in what form? Slope-intercept, right? And what's so damn good about me giving you the equations of those lines in slope-intercept form? You're supposed to look at the slopes when you talk about parallel perpendicular, right? All you're supposed to do is compare them. And if I give you the line in y equals mx plus b, then you see them right there. There's the slope, 1/2 and -2. So are they parallel? No, because those would have to be the same exact numbers. Are they perpendicular? Yes. Why? They're negative reciprocals, or you could say that they multiply to be -1. Either way, our conclusion is that they're perpendicular. All right? All right, let me give you some problems to do out of the homework section here. This is going to be on page 238. Um, 11 through 21. Oops, 11 through 21. Odd. Now make sure you read the instructions on these. It says here for those to identify the slope and the y-intercept.
So they give you an equation, and then you have to make it look like y equals mx plus b, and then you just say what's m and what's b. So you're turning the equation into that special form. It's not asking you to graph, okay? Numbers 41 through 51 odd. Now those are graphing problems, okay? Those are graphing. They say write it in slope-intercept form and then graph. And then 53 through 56 all. Now those problems, 53 through 56, are like the ones I just showed you. You get L1 and L2. You look at their slopes. Are they parallel, perpendicular, neither? So that's going to be pretty quick. And then finally, 69, 71, and then 75 is probably going to be the hardest one in this homework assignment. That's like that one I did just a little while ago where I gave you the slope and I gave you a point. What was the point I gave you? It was like 5, -4, and we had to somehow figure out what b was, and it came out to be that weird fraction. Number 75 is just like that. All right, y'all okay? Okay, last idea or last topic here. Something called the point slope formula. Now, we just had something called the slope-intercept form of a line, right? Y equals mx plus b. Yes? This is actually a formula that we use to create a line if all we're given is the what and what, do you think? A point and a slope. If somebody gives us a point and a slope of a line, we can use this formula to come up with the equation of the line. So I'll put here, given any point, and that's the big thing, any point, and we'll call it x1, y1, and the slope, m, then the equation, that's not equation of the line is, and here's the formula, y minus y1 equals m times x minus x1. Yes, I would write that down on my cheat sheet. All right, let me show you how this will work. As an example, find the equation in slope-intercept form of line through 2, 3 with slope -4. Okay, so what have I given you in this problem? I gave you a point on the line, right? And I gave you the slope, right? I gave you the point and the slope. So that should start making you think point-slope formula. Now, I asked for the equation in slope-intercept form. What does that mean? That means my answer needs to look like y equals mx plus b. That's what that means. So I want your answer, the equation of the line, to be written in slope-intercept form. All I'm giving you is the point and the slope. So let's use this red formula up here. What can I write here? Well, the 2 is x1, the y1 is 3, and then, of course, the m is negative 4. So if I rewrite that formula, it becomes what? Y minus 3 equals negative 4 parentheses x minus 2. That's it. Now, that's an equation, but it's not done because I asked you to put it in slope-intercept form. So we have to get it y equals mx plus b. So what you would do here, look at that little thing like bouncing back and forth. I don't know why it does that. Okay. What we need to do is get the y by itself, but we also need to distribute the negative 4 through. Okay, so let's distribute negative 4 through. We get negative 4x plus 8. Now we will add 3 to both sides, yes. That'll get our y by itself. So y equals negative 4x what? Plus 11. And that is the equation of that line in slope-intercept form. So what I can guarantee you is if I did things right here, that line has a slope of negative 4, which I think you can tell, right? Because the slope is negative 4 in front of x. But it also passes through the point 2, 3. Okay, one last problem, and then what I'm going to do is I'm going to give you one. And then once you've done it, you can leave. This is kind of the grand finale. Find the equation in slope-intercept form. What does that mean I'm going to want? Y equals mx plus b of the line through 1, negative 1, and negative 1, negative 5. I really like this type of problem on a test. Okay, so what have I given you? 2 points, right? 2 points on the line. The formula we just used was called the point-slope formula, right? Point-slope formula, which meant that we had to be given a point on the line, right? And the slope of the line. Here I have not given you the slope, have I? I've given you a point, haven't I? Actually gave you 2 points. But you have at least 1 point, don't you? But you don't have the slope. However, what? I didn't give you the slope directly, did I? I could maybe graph it, but even without the graph, how can you find the slope of a line? Solve m, right? I mean, what's the formula for m? y2 minus y1 over x2 minus x1. But to do that, you have to have 2 points, don't you? Well, you have 2 points. So what this problem requires is that, look, hidden in here, there is a point, right? x1, y1. So you have a point. You don't have the slope, but by using the other point and calling it x2, y2, I can calculate the slope to be, in this case, negative 5 minus negative 1 over negative 1 minus 1, which is negative 4 over negative 2, which is 2. Ooh, okay. There's lots of signs there you got to be careful with. Y'all understand what I just did there, though? Yeah? Okay, so now I have a slope, don't I? And I have a point. Now, which point should I use? Yeah, x1, y1. I mean, it doesn't matter. You could actually use either one. You get the same answer. But I'm just going to pick, I'm going to use the first point. So here's my point, and here's my slope. Now I use that formula that says y minus y1 equals m times x minus x1, the one we just talked about. Replacing my y1 with negative 1, so be careful with the sign there. M is 2, and then x minus positive 1. Do y'all see where everything comes from there? That's y plus 1 equals 2x minus 2. I'm distributing the 2 through the right side and changing the minus negative 1 on the left side to be plus 1. Last thing to do, subtract 1 on both sides, and you get y equals 2x minus 3. That's it. Okay, I'd like you to do this one, and then you can go after you show it to me. But I also would like to make sure that I give you your homework assignment. So homework page 248. 11 through 11 through 17 odd, and then 18, 19, 20. See how you do with those. Now, for right now, here's what you can do. Your problem is find equation of line that goes through the 2 points -2, 7, and okay, I got to make this work. Hold on. -3, 2. There you go. Oh, and when I say find the equation here, I mean in slope-intercept form. So I do want you at the end to put y equals mx, right as y equals mx plus b. Everyone understand what's being asked? You got 15 minutes to do that. I'm going to count it as a quiz grade, more for the effort you put in, but I do want to see that you get to the right answer. Try and do as much of it on your own, but if you need help, raise your hand. I'll come help you. You can use your notes and everything else.